In question 7, we are given a function describing Fiona's speed t minutes after passing a point A on the motorway. In part A, we must find her speed when she passes the point A. This occurs at a time of 0 minutes, so all we need to do is sub in t equal to 0 into our function. In part B, we need Fiona's acceleration 5 minutes after passing the point A. Acceleration is the rate of change of speed, so we can obtain the acceleration function by differentiating the speed function. We're working with a time of 5 minutes, so we sub in t equal to 5 to get our answer. In C, we must find the time in the first 4 minutes at which Fiona reaches her maximum speed. Maximum points occur when the derivative is equal to 0. We found our derivative in part B, so we can set this expression equal to 0. We're left with a quadratic expression, and this can be solved using the quadratic formula with A equal to 2, B equal to minus 12, and C equal to 13. We end up with 2 solutions, but only one of them occurs in the first 4 minutes, t equal to 1.42. We can verify that this is indeed a maximum point and not a minimum point by showing that the second derivative is negative at t equals 1.42. In part D, we must use integration to work out Fiona's average speed over the first 5 minutes. To do this, we integrate our speed function between the limits of 0 and 5, and then divide by the length of the interval, which is simply 5 minus 0. Each of the terms in the function can be integrated using the rule of raising the power by 1 and then dividing by the new power. We sub in the upper limit of 5, sub in the lower limit of 0, and then subtract. Performing this calculation brings us to our final answer. In E, we are given information about the values of the first and second derivatives when t is equal to 1. V dashed of 1 being greater than 0 tells us that the function is increasing at t equal to 1. V double dashed of 1 being less than 0 tells us that the rate of ascent is getting smaller. B is the only graph with these two properties. In part F, we need to find the minimum time required to travel a 10-kilometre distance from A to B without ever exceeding 100 kilometres per hour. To minimise the time, we should travel at exactly 100 kilometres per hour for the entire journey. The time can be found by taking the distance, 10 kilometres, and then dividing by the speed, 100 kilometres per hour. This comes out to be 0.1 hours, which is equal to 6 minutes. In part G, Rowan travels the 10 km distance between A and B. In the first section of his journey, which lasts 2 minutes, he travels at a constant rate of 120 kilometers per hour. This is equivalent to travelling 2 kilometers per minute, so he will cover 4 kilometers in this time. In the second section, he decelerates at a constant rate. We are told that Rowan's average speed is 10 kilometers per hour, and from part F, we know that this leads to a total journey time of 6 minutes. Since the first section lasted 2 minutes, the second section of the journey must last the remaining 4 minutes. The overall distance is 10 kilometers, and since we travelled 4 kilometers in the first section, there's 6 kilometers left over for the second section. So, over the second section of the journey, Rowan has travelled 6 kilometers in 4 minutes. Scaling up by a factor of 15, we can deduce that Rowan has an average speed of 90 kilometers per hour in the second section. He starts at a speed of 120 kilometers per hour, so to end up with an average of 90, he must finish with a speed of 60 kilometers per hour. In other words, his speed decreases by 60 kilometers per hour over a 4-minute period. This corresponds to a deceleration of 15 kilometers per hour per minute.